Hey everyone, it's Cliff. After a long break, I'm finally back making some videos. I have a lot of projects in the backlog, like I normally do, and so I'm finally getting around to clearing out my kind of my area where I have all my computer stuff that needs to be done. Trying out another filming setup, so I'm filming in 1080p, 60 FPS hopefully, and my microphone should still be working as well. So I'll figure that out after I film this clip. But anyway, enough rambling. In front of you, and I guess me, we have a HP Z820 workstation motherboard. So a little bit of backstory. I bought an HP Z820 off of eBay for a project, and then it ended up having a bad cap on the motherboard right here, and this one it's good. So I asked the seller if I could just get another board sent to me. Instead, they sent to me an entire case, chassis, and motherboard assembly. So I ended up with two cases, two chassis, case and chassis, same thing, motherboard, power supply, basically everything I needed for a second system, just not replacing the motherboard. And they didn't ask for the old system back with the defective capacitor. So now I have two systems. Well, two systems, one with a bad motherboard. So my original goal was to get I actually ordered and I have a new solder kit, and I actually desoldered the cap here, but I did such a bad job that I ruined the board. I guess that's all part of the learning experience. So this is a board that I bought off eBay, one that has all its capacitors all good and hopefully working and ready to go. So right now there are two, I think four core. I was gonna say three core doesn't exist for Intel. Four core Xeons. I think they're the first generation of the E5s, which are Sandy Bridge based. I have with me a couple of the Ivy Bridge based. I think these are E5-2667 V2s. These are 8 core, 16 threads. These are pretty cheap on eBay nowadays. I think they are clocked at 3 gigahertz, and I believe they turbo up to 4 gigahertz. So between these two CPUs, we'll have 16 cores and 32 threads. So not a bad workstation. Obviously, power consumption will be high with having two CPUs. In terms of memory, I got a lot of DIMMs for my D30. I'm also selling my old Lenovo ThinkStation D30. I downgraded that machine to 64 gigs of RAM, and this is 128 gigs of RAM in all these modules. Look at me making the camera zoom in and out. So I have that's 16 8 gig modules, which give 128 gigs of memory between all, I guess, two CPUs and the four memory channels in each CPU. So you have in these multi CPU setups, you have two memory architectures. I think it was a NUMA, non-uniform memory architecture. So basically, CPU 1 has access to this RAM, CPU 0 has access to this RAM, and if you do incur a penalty hit, if you have to, you have an application that consumes more than the CPU's local memory. So each CPU will have 64 gigs of memory, and if you have a single continuous job that goes over it, you'll have to go over, I believe, I think they're UPI links or QPI links. I'm not 100% sure, but the logic that connects the two CPUs together, they have to go through to access the memory. So normally they try to schedule it so that the memory only accesses the local CPU's RAM. But obviously that's not always necessarily the case. Besides that, motherboard looks like it's in okay condition. I'm going to go ahead and clean it a little bit. It's got a little bit of dust. And I took these off the dead motherboard. These are like the lug nut screws. The way that this board kind of installs, and I'll show you, my hand motion, is it kind of just locks into the case with these kind of like bolt things and nuts. But jeez, this is a serious channel, and then it locks in the case. So I'm gonna go. I took these off the dead motherboard. That's what I'm trying to say. And I'm gonna go ahead and put the CPUs in. Get the RAM put in. Get the nuts installed, and then I'll show you. So I'll be back in just a second. And just like magic, I have the new CPUs installed. New used CPUs, and our 16 DIMMs installed. Looks very nice. I cleaned up the motherboard. Here are the old, here, let's see what these were even in here. If I could focus. E5-2630s. Yeah, I think these are 4-core CPUs or 6-core CPUs. Who knows? Well, they're not being used right now. I know these are 8-core CPUs. All right, let me go ahead and get the case on the table. I already hollowed out the case. I removed all the components. I basically have every single component outside the case. So I'm going to go ahead and start reassembling it now. So see you in a second. Empty case. So here's the hollowed out Z820 case. It's got all the leads all here, all ran, ready to go basically. Here, I do a little bit of unplugging, SATA cable. But gonna go ahead, install the motherboard, neaten up these wires. There's some cable management. You can't really see them with the camera angle. Some cable management, I want to say arms, kind of like punch outs here. So got to get all these cables nice and neatly organized, plug in all the power, and then you should see a nicely installed and set up system. in just a second. So, be back in a flash. And after a few minutes, we have a nice motherboard installed and our cables all nice and neatly routed. The one thing I do like working with OEM systems like this is that, they build them most of the time intelligently, unless you're like a modern Dell or modern HP or modern Lenovo. But I guess any modern OEM, but the older ones, they used to make it, nicer. And, I have this nice band of ribbons for all our cables. The SAS connectors all, nicely cabled up. Now I just need to install the case fans, the PCI fans, the heat sinks, drive cages, and the air baffle. So that's next on the list. But it's a very clean build, very nice. I do really like these systems, and I do like the contemporary Lenovo systems, the D series. But I haven't tried the Dell Precisions. It's the only one of these, kind of like the big three that I haven't tried. So anyway, enough rambling. Let me go ahead and install the rest of the case components, and I'll be back in a flash. And one DaVinci Resolve transition later, we have a more complete looking system. I got all the case fans installed, the case peripheral components, the PCI fans, which have these nice little clips for the graphics connectors, which are very nice. Unfortunately, I only have two drive caddies. I ordered the other two. They're coming from China. It might take a little while, but two will get me by in the meantime. I have the heat sinks installed, and now I just need to go, if I could walk over here and grab the air baffle. This kind of has like the like all the fans integrated into it. It's this big plastic assembly, and this just slides right over it. Like gotta line it up. Easier said than done. Oh nope. Gonna reposition. There we go. So that's all installed. I like it. I like the engineering in this system, if you haven't guessed. But that means that's all good. I have the last component over here. Oh, there's something I forgot to do. Whoops. I have the PCI baffle that goes kind of like hooks in like this, and then that goes clips in like that. I just forgot to put in the SATA cable for the DVD drive, so I'll make sure to do that. And I need to put in a GPU. So a little note about the GPU. I have the other cable coming for it as well. I have something I could use in the meantime. But these, they're only 6-pin PCIe connectors, 3 of them. These are non-standard for what I've researched, what I've been told. These are actually 150 watt 6-pin connectors. Usually an 8-pin connector is 150 watts. So if you get an adapter that HP made, which I have on the other Z820 that I have, then it converts this to a normal 8-pin. So because there's 150 watts on it, there's I think it's because there's 2 cables routed to certain locations. I forget exactly how they did it, but this is non-standard 6-pin spec. So I have a splitter cable that I'll use to power the GPU, which we'll be using for this. This is an EVGA GTX 1070. You can read it right there. Someone gave it to me. They just handed it to me and said, "You want this?" And I'm like, "Yeah, sure, I want it." And I'll go ahead and put it in this system. So this will be the primary GPU, and I'll also add a wireless card. So let me go ahead, get the GPU hooked up, the wireless card installed, the DVD drive hooked up, and we should be good to go. So be back in a few. Got our GPU installed. Looks like I have my own ghetto 12-pin adapter, except this is an 8-pin to the dual 6-pin adapter. Hopefully no fires. I know the GTX 1070 works. I tested it after a person gave me. It's kind of hidden back here. I also put in an Archer Wi-Fi card. I think this is an Atheros chipset. Wireless AC PCIe card. And I also put in, here, I can pull it out. Put in one of these little Asus Bluetooth guys, just so that has Bluetooth too as well, because it's not built into that PCIe card. All right, so I'm going to go ahead and seal it up. The last thing I'm going to do, if I can actually plug in a USB device, the last thing I'm going to do, make sure this actually clips in, or need to make sure it fits in this little kind of like area, or at least the power connector does. All right, let's see. Perfect, like a glove. So it's all set up. Just need to do some cleaning of the exterior. I'm going to install an SSD. I'm going to put in a 2 terabyte SSD that I'm using for my personal use in order to do some testing. I bought a 512 gig HP branded SSD to be the boot drive, and I have a 2 terabyte hard drive that I'm going to use as a data disk. But I'll put a 2 terabyte SSD in here to start, just so I could do my benchmarking, maybe play a few games and give you an overall idea of the system. But let me go ahead and clean up the case, get it stood up, and power it on. See the moment of truth. One thing I worry about is that I did not update the BIOS. So I don't know if it supports the CPUs I put in there. Should have probably done that before I did anything, but fortune favors the bold. So let's go ahead, close it up, and get ready to power on. So see you in a few. Okay, moment of truth. I have the case all cleaned off, ready to go. Monitor plugged in, powered on. I'll hit the power button. Hopefully nothing explodes. Definitely running at full fan power. It's not a good sign right away. Let's give it a little while. Hoping this means it doesn't need to have the old CPUs put in and then the new one's taken out. But you can hear it's probably like a wind tunnel right now. Okay, let me cut it here, and then I'll get back to you once I figure out what's going on. So I really did jinx myself there. It turns out I needed to put in the original Sandy Bridge based Xeon. Now I can actually boot to the BIOS. I pulled both of the Ivy Bridge Xeons, left only one of the put one Sandy Bridge back, and I'm going to update the BIOS. I think this J63 version 3.14 is very, very outdated. So I'm going to go ahead and update it and then see if I can put the Ivy Bridge Xeons in. So it's going to be a bit of a project. I'm going to go ahead and do that now. It might take me a little while, but I will be right back. In your eyes. Okay, so after quite a few hours of debugging and actually just, looking information up, which I usually should do before I film any video or buy any project, but, as I continue not to learn from my mistakes, here I am again. Now these are not Xeon V2s, these are Xeon, I guess V1s, or technically just, there's no version number behind them or after them because these are E5-2690s. Because it turns out, even though I have the Rev 1.02 motherboard, I have a motherboard that was shipped earlier with a BIOS boot block of 2011, which means it only supports Sandy Bridge CPUs, so no Ivy Bridge support. Even if you upgrade to a BIOS that does support Ivy Bridge based Xeons, it will not work because of that boot block. So that was unfortunate, but luckily these are actually from my D30 that I'll also be selling. So in the D30, a couple years back now, I actually bought the. I think I made a video of it. I actually bought the Xeon E5-V2 compatible motherboard and did a swap there because that I knew ahead of time. But with this HP system, I thought it was just all the same board. You just did a BIOS update. But oh well. Well, hopefully, if you're watching this and you're thinking of getting one of these machines, that's something to look out to in the future. I'm just getting really tired of repasting and unpasting CPUs because I think this is like the 5th or 6th time now I've gone through both sets. So quite a few cotton swabs, quite a few. A lot of rubbing alcohol was spilled, but anyway, I also took out the half the RAM. I'm going to move that over to the D30, and if you could tell, this is not the GTX 1070 anymore. This is the GTX 980 Ti. I was going to make a video, separate video with the D30 that I'm selling, going over the this GPU in particular, just seeing how it performs in 2023, I guess really almost 2024 now. But because this will be running the Sandy Bridge CPUs and D30 will be running the Ivy Bridge CPUs, I'll give the older GPU to the older CPUs, kind of pair them together, because I'm going to be selling this system too as well. So I'll be selling with a 980 Ti and 32 gigs of RAM, whereas the D30 I'll be selling with the Xeon E5-V2s, the dual 8 cores. These are also dual 8 cores. These are clocked at 2.9 gigahertz. I think these are the fastest that are available for the two-socket platform. And the ones I have obviously pulled were clocked at 3.3 gigahertz. So you lose a lot of clock speed and also IPC improvement. But luckily, feature-wise, they still have AVX support, so you can launch modern games with them. But we'll go ahead and see how this GTX 980 Ti performs. 6 gigs of VRAM, kind of a mid-range. That's a kind of like a mid-range card nowadays, but that used to be a high-end card back when this was new. And also the blower styro cooler also works a little bit better with this case because there's not really as much open ventilation with that big giant shroud that comes down. And then that's about it. I moved the wireless card down to the PCI Express 2.0 slot to free up the PCI Express 3.0 slot because it makes no sense to put it in there if it doesn't really need that much bandwidth. Also, PCI slot. Don't see those many that often anymore. But gonna go ahead and put the heat sinks on, put it to BIOS, do one last check, and then I will install Windows 11. So be back hopefully quicker than I was before because a few hours have passed in real life. So, all right, see you after one DaVinci Resolve transition. All right, now we finally have our system booted up and working normally. As you can see, this is what caused the issue. Boot block date. Boot block date 12/28/2011. So that means you're capped to Sandy Bridge processors. So I have our two Intel E5-2690s at 2.9 gigahertz. Again, those are still 8-core, 16 thread. Just happens to be their Sandy Bridge instead of Ivy Bird base, and they also are clocked lower and obviously have lower IPC. But besides that, I have the BIOS updated to the latest revision. I have the firmware also updated to the latest revision as well. And I'm going to go ahead, set some BIOS settings, and install Windows 11. My thought process is installing Windows 11 is that obviously Windows 10 is actually going out of support pretty soon. You have all 2024 left, and you have some in 2025. So might as well put Windows 11 on for now, even though it's technically not a supported system. I don't think Microsoft now has the ability to kind of like put the genie back in the bottle, if that makes any sense, because how many systems are running, Windows 11 that technically weren't compatible. Because I think at Windows 12 they'll actually make it a real requirement where if you don't have this, it just won't work because Windows 11 is just Windows 10, but with additional features that require, a TPM 2.0, a supported processor. Whereas this system, the Z820, has UEFI, Secure Boot, and a TPM, but only a TPM 1.2 chip. So not a TPM 2.0 chip and not a supported CPU, even though an 8-core, 16-thread CPU can run Windows 11. Two of them, believe it or not, can run it just fine. So I'm going to go ahead, set some BIOS settings, and you'll see me booted back into Windows 11.
Okay, so I think it's actually, what is it? The date is the 2/18/24. I believe I filmed the earlier segments of this video back in November of 2023. So I'm a little delayed, but better late than never. I kind of pieced together that the last thing I was doing in my last video segment was I was in the BIOS, confirming the BIOS settings, and getting the system ready for Windows install. So luckily, as you can see, I've gotten the system installed. This is actually using my test drive, which I recently created. This is a 2 terabyte SATA SSD that I'm basically going to use between all my systems. But we have our dual Xeon E5-2690s at 2.9 gigahertz. These are the fastest CPUs you can get for the Z820. There are 8 cores and 16 threads. So in total, we have 16 physical cores and 32 threads. And if I go into the device manager, we can see that all of our drivers are installed. I have the latest. I just installed the latest driver for our 980 Ti. 980 Ti. Oh, man, having a rough one. All of our network devices. I had that wireless card in there. Let's see. Let's go down to. Oh, I don't see the TPM. Oh, interesting. I must have enabled it. Interesting. Okay. Well, I guess we're riding without one for right now. Okay. Well, that's not really going to impact the video, but you can see all of our CPUs detected in Device Manager. Let's go ahead and fire up CPU-Z. Hardware monitor, GPU-Z. See what we're idling at. And then we're going to play some games with our lovely Activate Windows watermark in the bottom right-hand corner. Not going to bother activating this copy. It's going to be moving between systems. Okay, so what are our temperatures looking at right now? It's not bad. One of the CPUs is about 30s. The other CPU's in 30s too as well. Obviously, this is under gaming. I'm going to leave this running while I play some games. And we can see we have our Intel Xeon E5-2690. This is Sandy Bridge EP, 32 nanometers. Definitely getting a little long in the tooth. 135 watt TDP. So pretty high power chip back in the days. I mean, nowadays they are sacrificing efficiency for higher performance gains at the top end of the product stack. Especially I'm looking at you, 14900K. That just rolls off the tongue. In their 300 watt TDP draw or power draw. We have our 64 gigs of DDR3, and this is in quad channel. It's running at 1600 megahertz, so the frequency is 800 megahertz, double pump to 1600 megahertz. We could go through our SPD. I think of the latest BIOS for this model revision. It's the 2019 date. I've got to check about the TPM when we chance. Okay, we have our 980 Ti. Another thing that's also getting long in the tooth. I'm surprised that NVIDIA is still supporting these with the latest driver range. Them hearing me say that, they're going to immediately drop it off their support list. But a few, I guess I wouldn't say some important systems still run Maxwell, which is what the 900 series was. That's what the GM for graphics Maxwell or whatever, I believe. But Maxwell is still the earliest supported for DX12 Ultimate, I believe. So any game that requires actual, or not maybe Ultimate, but actual full DX12 support. So any game that you need full DX12 support, you'll need a Maxwell GPU. So the Nintendo Switch uses a Maxwell-based GPU in its graphics core. I believe it's a semi-custom job. Well, it is a custom job, but that's probably the most recent machine that's still running Maxwell. That's still in max production. But we got our 6 gigs of VRAM, which is going to be important for playing modern games at 1080p. And this card launched on June 1st, 2015. I believe the 980 launched in Q4 of 2014. So we're basically gaming on a 10-year-old chip now. Which is good. I get to say this is a video that is how does Sandy Bridge EP and a 980 Ti hold up in 2024 now, not just 2023. All right, getting it all the way. I'm going to go ahead and start a city bench run. We'll benchmark the CPU, and then after that's done, I'll also run a pass mark, and we'll just benchmark the whole system. So let's see if I'm going to go ahead. I'll cut it right here, and I'll be back as soon as this test refines. So I'll be back in just a second.
All right, so our Cinebench actually on R23, if you can see now, heads up to anyone trying to run the latest version, which is actually, I believe they just call 2024. It requires AVX2, so these older E6 26 E5-2690s, which are Sandy Bridge based, only have AVX1 or original AVX, so it will not run the latest version of Cinebench. So try using R23 if you need to benchmark these CPUs. So you can see our test finished up. We finished with 11,754 points. That puts us a bit under, maybe like not, I would say half of a 1950X Threadripper, but maybe 60% of it, 70% of it, which is kind of pitiful considering that they're both 16 core CPUs. It just shows you the difference in IPC and also clock speed. The Threadripper is clocked a little bit faster. And also, obviously, it's much newer. It uses DDR4, has AVX2. So you can see that workstation-wise, I mean, we beat a 1700X, which is a 8-core processor. And again, this is multi-threaded, so we're not talking about single threads score yet. And we beat some older Xeons in just this kind of generic ranking chart that they have. But for the power consumption, like see this 9980H. Man, I gotta work on my Intel nomenclature, but it's a mobile CPU. It's a mobile 8-core CPU, and it's only a couple thousand points less than our, oops, sorry about that, our dual, our dual, power hungry Xeons, which is going to be something to talk about. Because if we go over to a hardware monitor, I had this running in the background. Our CPU is maxed out at about 78 degrees, almost 80 degrees Celsius, both running that full load. I could probably tweak it higher in order to get it or you could tweak the fans higher in order to get it better, or better thermals. But for the configuration I have it running right now, that's a little toasty. So, all right, enough rambling on multi-core. Let's go ahead. I'm going to start this single core right now, and then I'll be back again in a few.
And after a very long single core test, we have our results. We've gotten 635 points in single core, which puts us just where I expected it to be, at the bottom of the list. We're beating in this little demo list they put together. We're getting beat by basically everything. We're 7700K and 9900H, that 1700X easily trumps these older Xeons in single thread performance, which is, as I said, to be expected. Really, these CPUs didn't have the best IPC when they launched. Well, I mean, they did, but they didn't have the highest clock speeds, and they didn't, the all-core turbo on this machine is, I believe, 3.8 gigahertz, which is still pretty good, but, I mean, it's just not meant for single-threaded applications. They're meant for multi-threaded applications. So let's go ahead and launch our next benchmark. I'm going to go ahead and try a pass mark, and I'll be back again after this finishes, hopefully less than 15 minutes like it took for that Cinebench single-threaded test. So, be back in a second. Hi, post-clip here. Unfortunately, the later clips ran into some audio issues, so I'm actually recording this via voiceover. I guess what it boiled down to is I'm using my Pro X with direct capture, and it must have either timed out or I must have turned it off. I don't think I would have turned it off, but the Halo Infinite clips and the clip of me playing Starfield have my audio enabled, but you'll still hear the game sounds, but you won't have to endure my annoying voice in the second half. Anyway, here's our pass mark scores. As you can see, we got in the 54th percentile, mainly carried by our CPU and 3D graphics marks. So our CPU is still holding well because we have plenty of physical cores, even due to the age, and our graphics mark is still pretty well, considering that even though the 980 Ti is about a decade old, it was still a flagship back in the day. So I guess you're going to be hearing me throughout the video game clips, but you won't hear too much of me if you're appreciative of that. Otherwise, enjoy some ASMR while you watch the rest of the video, and then I'll cut back to my final recap afterwards. So I guess enjoy the rest of the show. Alright, we've loaded into a game of Halo Infinite. This is running at 1080p with the medium preset selected. I haven't made any changes besides that. One thing I noticed is that our GPU utilization is at almost 100%, so this game is pretty well leveraging our 980 Ti in here. And we're getting a pretty good frame rate. We're averaging about 70 FPS. This is a big team battle game. Thought that might be a bit more stressful than maybe one of the smaller maps or one of the smaller game modes. But no, just fine. We're getting the 60 FPS range. Our GPU is definitely running a little hot. I'm surprised that the fan hasn't ramped up a lot, but maybe I could like change that if I had to. Oh man, I'm gonna be playing terrible trying to do this and and comment at the same time. One thing I noticed is that loading times were pretty long, so especially the first boot, but I think it was optimizing shaders, so that's expected. But to get in the game, it took a little while. I think the game had already started by the time I joined, but if it didn't, it definitely took me longer to load into everyone else. But I mean, this is like I said, this is running at medium, and we're getting some pretty good. Oh, here got bored. Someone just bored stole that from me. We're getting pretty good frame rate, all things considered. So, I mean, like, this is definitely playable, and you can even drop it down to low if you need to. Getting a little bit, I don't know if you noticed it, I don't know if this is just my capture card or something, but getting a little bit of some inconsistent frame times, though, which would be something to worry about if this was energy switch. Oh, I'm gonna die anyway. It would be a little bit worrisome if you're trying to play, obviously, at like a competitive level, but if you're trying to do that, you probably want to buy a better system. So, alright, that's the first game. Let's go ahead and try another game. On to the next game. I loaded up Starfield. Again, this took probably about 20 to 30 seconds to launch, and I'm talking about just launching to the main, title screen, so I can hit continue or, load game. And here we are on Kilo City. It's been a while since I played Starfield. Kind of fell off, I guess. But right now we're running at 1080p with the low preset, with FSR or any resolution scaling disabled, and we're averaging about 30 FPS outside. As you can see, we're still kind of GPU bound on our 980 Ti, so we might have some headroom with a better GPU. But one thing I was going to try, so let's go into settings. Let's go to display, and let's actually enable FSR. So let's go down to upscaling. And let's use FSR, and let's see, render scale, it looks like it's at 2/3. Okay, let's see how much better FPS we get. Barely any. Okay, it was worth a try, but this is still playable, obviously. I need to try to get in a fight somewhere, or shoot something, but
hair trigger there.
sorry, Sam. But with this being the outside area in a large city with multiple AI, this would be playable. I mean, this is probably more a result of Bethesda optimization more than anything else. As you can see, Halo performed much better, but then again, it had a lot less I had to keep track of physics-wise and graphics-wise. But no, seems to be fine for experience considering the age of the hardware. And then let me go ahead and let's try another game. Post-tier cliff, yet again, this was filmed at 1080p with a low preset and no resolution scaling, so that was turned off.
Who lived here, I wonder?
I hope you have your affairs in order.
And this clip of Doom Eternal was filmed at 1080p with no dynamic resolution and the medium preset. And this clip of the Dead Space 2023 remake was filmed at 1080p with the low preset.
This is all I got left!
And much like the previous clip, this clip of Battlefield 2042 was filmed at 1080p, no dynamic resolution scaling, and at the low preset.
Sector Charlie has fallen. and secure. Sector Delta has been captured by us.
And last but not least, this clip of Cyberpunk 2077 was filmed at 1080p with a low preset and dynamic resolution scaling off.
Okay, so my final kind of thoughts or my closing, I guess, statements on the Z820 is it's still a good machine, as we demonstrated, even with this old 980 Ti in here. I mean, if you get one of these systems cheap, it's always worth it. I mean, power draw considering. Try to get one of the later models. So this is one of the earlier models that can only run the Sandy Bridge EP Xeons. The later revisions can run Ivy Bridge based Xeons. So try to get that one if possible. But they're basically identical besides that. You still have plenty of room for expansion. There's plenty of wattage, especially if you get a one of these 1100 watt power supplies, and you do have three PCIe connectors. These are non-standard 6 pins, so if you need an 8 pin, you need an adapter that just kind of breaks it out. Each of these are 150 watts, so they're basically like an 8 pin but in a 6 pin form factor. But besides that, no, still a good system. I'd say this is the oldest you want to go nowadays. If you go any older, you're going to lack AVX support. I'm talking the Nehalem Western Mirrored base Xeons. Stay away from those now. If you plan to do any sort of gaming. If you just plan to use it as a computer, still fine. But I really suggest trying to go for a Z840 if possible. So the Z840 has some better I guess more ancillary features or, more future-proofing in a sense. The Z840 has a TPM 2.0 chip, which I think will matter as we go on, whereas the Z820 only has a TPM 1.2 chip. The Z840 also has AVX2 support in their CPUs, which will also probably be needed. And additionally, you have native NVMe boot on the Z840. So if you can't swing it, try to go for Haswell or Broadwell-based systems. But Xeon, Sandy Bridge, and Ivy Bridge still got some life in it. Especially, you still have PCIe Gen 3. You could add NVMe drives. They won't be your boot drives. You could do it some non-native ways, but you won't have native boot. But you get plenty of RAM. You could go up to 256 gigs of RAM if you needed to. And even on this older Sandy Bridge base model, you could get up to 16 physical cores. So good amount of physical cores. The only thing is you'd be drawing a lot of power, but that's basically every single system nowadays. So, all right, I hope to get a new video uploaded, somewhat regularly now. I'm going to see if I could try to break these into smaller videos that are more manageable, considering this long, giant, mess. I think this is probably going to be about almost an hour once I cut and upload everything over the multiple months I filmed it. But I was thinking maybe I could stick to, sub 10-minute videos and do multiple parts. And my next video is going to be on a another Xeon. It's going to be on the Xeon Scalable, the first generation system. So stay tuned for that. Thank you for watching. If you made it this far, I don't know why you want to torture yourself, but I appreciate it. And I will see you in the next one. Later.